All right, what's up? Let's take a look at the tangent and velocity problems. This is typically the first section you'll come across in calculus after all the algebra and review and trig review and stuff. So let's look at this first problem here, and what this is going to do is going to kind of give you an idea of limits and stuff like that. It's going to get you ready for all of that stuff. So let's find an equation of the tangent line to the parabola y equals x squared at the point 1, 1. All right. So we've got the point 1, 1, and we want to find a tangent line at that point on this curve y equals x squared. Well, let's sketch a graph. So if we graph this thing, it's going to look something like this. And of course it'll come back this way too, but we're not really worried about this side because the point we're looking for is right here at 1, 1. Okay, this is where x is 1 and y is 1. And I don't know, let's just call this point P. We'll put it here. Let's see, P is 1, 1. All right. So the line that we're looking for is this one right here. This is the line that's tangent to this curve, y equals x squared, at the point 1, 1. Now, if you know, in order to find the equation of a line back from algebra, we had this, y minus y1 equals m times x minus x1. Remember, this was the point slope form of a line. And in order to find the equation of a line, we needed the slope of the line, which is m, and we needed, okay, so m is the slope, and we needed a point on the line, which was x1, y1. And there were different ways you could find the equation of a line. They could give you the slope and a point, or they could give you 2 points. Well, if you remember, if you had 2 points on a line, say x1, y1, and x2, y2, then the slope of the line was y2 minus y1 over x2 minus x1, where x1 did not equal x2, because that would make it undefined. Okay? So that's just a quick refresher on how you found the equation of a line. All right, so that's all we're doing here, is finding the equation of a line. Well, if we look at our problem here, we do have a point on the line. We've got this point 1, 1, but we don't have the slope. We need the slope of this line. So how do we go about finding the slope of the line? Well, that's kind of tough. Later on in calculus, there will be an easy way for you to find the slope, but we don't know how to do that yet. So let's do this. Let's pick a point here on the line. Let's pick another point and call this point Q. Okay? And I don't know. Let's just say that we're going to pick 1.5, and then if that's 1.5, then the y value would be 2.25. Okay? And if we found the slope, and see what this is going to do, and I'll do it in a different color, that's going to give us this line right here if we join those lines. But you can see that the slope of this red line is not the same as the slope of this white line. Okay, they're not the same. But if we did find the slope of the red line, Well, that's going to be what? 2.25 minus 1 over 1.5 minus 1. And that would give us 2.5. That's the slope of this red line. All right. So, and we can see that it's off quite a bit here. So what could I do? Well, what if I chose another point on the line, and then I connected it with this 0.11. Okay. Well, you can see that no, it's not the same as this white line. The slope of the blue line is not the same as the slope of the white line, but it is getting closer. And so I moved this point. See, this point here, I moved closer and closer to this point. Or another way you could look at it, you see that the x value is moving closer and closer to the x value of 1, which is the x value of this point. Okay? So what we can do, and let me kind of clean this up a little bit. It gets kind of messy in here. Let's see. I'm going to have to redraw this. All right. So what I'm going to do is I'm just going to pick some random point, and we'll just use this same point here. And let's call that point Q again. And let's just make it to where it comes out to some x value. Okay? Some x value. And if I'm at some x value here, then this right here is my y value, right? Well, we know that y is equal to x squared. So the y coordinate here would be x squared. So I just chose a random point here. And what I can do is I can find the slope. I can find the slope of the line that connects these 2 points here. Okay? So remember, that's y2, which is x squared, minus y1, which is 1, over x2, which is x, minus x1, which is 1. And so this would be the slope, and let me write this as the slope, and I'll put a subscript on there, PQ, to let me know that's the slope of the line joining the points P and Q. All right? So the idea behind this is to take this x value, okay, the x value of this point, and move it closer and closer to this x value here of 1 by choosing, x values that get closer and closer to 1. And that's coming in from the right-hand side of 1. And then I can also come over here and choose x values starting on the left-hand side of 1 and move closer and closer to the 1 from the left-hand side. All right, so what I'm going to do here is I'm just going to start a table. I'm going to have x, and I'm going to go ahead and start over here on the right-hand side and start just picking numbers to the right of 1 and move closer and closer to 1. So I'm going to choose 2, 1.5, 1.1, 1.01, and 1.001. Okay, so keep in mind as I'm choosing these x values that are getting closer and closer to 1 from the right hand side, See, that's giving me points that are getting closer and closer to that point. And then when I connect those points that are real close, that's the slope of that line is going to be real close to this one right here. All right. So these x values that I'm choosing, well, I need some values here. Okay. They're not going to be y values. Okay. I'm interested in the slope of the line. So I want to calculate the slope. So what I have to do is take each one of these values here and plug them into here to get the slope. So I'll just do the first one for you. So in this case, when x is 2, I'm going to plug the 2 in for x. So that's 2 squared minus 1 over 2 minus 1, which is 3. And so that would give me a slope of 3. And then I'll do that for each problem. For each x value, I'll plug into here and calculate the y value. And I'm just going to go ahead and write them down. I think you can do that. All right. So we can see that as these x values are moving closer and closer, and I draw these lines, and I draw the lines that connect each point with 1, 1, see the slopes, they're going 3, 2.5, 2.1, 2.01, 2.001. All right. Now, let's do the same thing coming from the left-hand side. So let's make another table. And choose values. So let's just start out at 0, 0.5, 0.9, 0.99, and 0.999. So in this case, see, I'm starting here and I'm choosing x values that are getting closer and closer to the point from the left-hand side. All right, so now I'm going to take each of these values and plug them into here just like I did these. So that's going to give me 1, 1.5, 1.9, 1.99, and 1.999. All right. So remember, I'm interested in finding the slope of the line. So I can see that as I'm approaching 1 from the right-hand side, see these x values are getting closer and closer to 1 from the right-hand side, it looks like my slope is approaching 2. And then as I'm getting closer and closer to 1 from the left-hand side, using these values, it looks like the slope is approaching 2 also. Okay. So I could actually come up here and write the limit. This is LIM. I know I write it messy, but that's what that is. LIM means the limit. So the limit as point Q approaches point P, okay, of the slope, okay. So that's this thing right here. The limit of the slope here as the point Q approaches P is approaching the slope of the tangent line. Okay? It doesn't equal the tangent line, but it gets closer and closer to the slope of the tangent line. It's approaching it. Okay? And so we could write this, the limit as x goes to 1. So see the limit as these x values here approach 1 of x squared minus 1 over x minus 1. We'll say that's equal to 2. And so this is the slope of the tangent line. And so now that we know the slope of the tangent line, we can find the equation of the line. So we've got y minus y1 equals m times x minus x1. And then we just plug everything in. Well, here's our slope, and then we know our point is 1, 1. So this is x1, this is y1, and the 2 is our m. And so I get y minus 1 equals 2 times x minus 1. So y minus 1 is 2x minus 2. And so y equals 2x minus 1. And that is the equation of the tangent line. All right, so let's take a look at this problem. It says, suppose that a ball is dropped from the upper observation deck of the CN Tower in Toronto, 450 meters above the ground. Find the velocity of the ball after 5 seconds. All right, so we want to know the velocity of the ball at 5 seconds. Okay, so this problem here, we've got an equation for the path of the ball. That's going to be s of t is equal to 4.9 t squared. All right, so at this point in the course, you don't need to worry about where that function comes from. You'll learn that later on. Okay, you've got more things to learn before you learn how to do this. All right, so just take it that this is the equation. This gives the position of the ball at any given time. Now, we've got a formula that says the average velocity is equal to change in position over time elapsed. Okay, change in position over time elapsed. All right, so let's just look at this. If we look at this function here, and all we're going to worry about is the positive part of it on the positive axis. Once again, we can see that's a parabola. This is our t-axis, and this is s of t. So the average velocity is what? The change in position over time elapsed. Well, the change in the position, that's the change in the s value over time elapsed. That's the change in the t value. Well, what is that? That's just the slope of the line. Okay? And we actually just want to know the slope of the tangent line when t is 5. Okay? That's what we're looking for. So if we look at this, well, we can figure out how to do this. Well, that's going to be just making a table out. So let's do that. So let's see. Let's do time interval, and then average velocity. All right, so let's see. Let's do a time interval. So we're going to go from 5 to 6. Okay? And then let's do another interval, 5 to 5.1. And I'll explain this after I write it all down. And then how about 5 to 5.05? And then how about 5 to 5.01? And then how about 5 to 5.001? Okay. So if you look at this, look, this is all I did, is I did the interval from 5 to 6, and then 5 to 5.1, and then 5 to 5.05, and you get the picture. What am I doing? All I'm doing is this 6, the 5.1, this one, and this one. Look, I'm just approaching 5 from the right-hand side. That's all I'm doing. Okay? So I need to calculate each one of these. All right? So I'm going to show you how to calculate the first one, and then I'll just write the answers down for the other ones. So the average velocity, and I'm going to abbreviate it here, AV, average velocity, is the change in position. So remember, the change in position, that's the change in the y value. Okay, that's the change in the y value. So let's suppose I'm up here at some point. Okay, I'm at this point here. Well, this value here, okay, so, well, I wish I could have drawn it a little better. Let's see. Let's do this. Give you a better idea. Let's draw the x-axis back in there. I mean the t-axis back in there. Let's call this right here, let's say that's 6. Okay. So the change in the y value from this point to this point. Okay. So this y value here is what? S of 6. And this y value here is S of 5. So the change in position here, that would be what? S of 6 minus S of 5 over the time elapsed. Well, that's just the 6 minus the 5. You see that? Okay. It's just 1 second. And so the average velocity would be 4.9 times 6 squared minus 4.9 times 5 squared over 1, 6 minus 5. Now all I did, S of 6 and S of 5, I plugged the 6 in for t, I plugged the 5 in for t. Okay, and then after you calculate that, you would end up with 53.9. Okay, so this would give me 53.9. And then you would do the same thing for each value here. Okay, the same thing for each value. So like I said, I'm just going to write the answers down for the rest of them, but you would work it just like I did the first one. And the only difference, see here, we would have 5.1 and 5.1 here. So this one is 49.49. This one 49.245, 49.049, and 49.0049. All right, so what that has done is that has given us the average velocity. I've found the average velocity over each interval. Okay, that's what these values are. But remember, they want to know the velocity at 5, which that is the, let's see, let's do this. That is the instantaneous velocity. Okay, so the instantaneous velocity, okay, after 5 seconds is what? Well, look what's happening. You see how these values, they're getting closer and closer to 5, and what is the average velocity approaching? we would say it's 49 and we would say it's 49 and we're in meters and seconds, so that's 49 meters per second. So that would be your velocity. Okay. All right, let's work one more. All right, so here's our next example. It says, if a ball is thrown into the air with a velocity of 40 feet per second, its height in feet t seconds later is given by this function here, y equals 40t minus 16t squared. Find the average velocity for the time period beginning when t equals 2 and lasting 0.5 seconds, 0.1, 0.05, and 0.01. All right, so they want us to calculate that. All right, so let's put it about right there. Let me write our function here so we can see it, because I may have to scroll up some more. Let's get about right there. All right, so for part A, I. All right, so for 0.5 seconds later. All right, so we're looking for the average velocity. So remember from the last problem, the average velocity is the change in position over time elapsed. All right, so if you remember in the last problem, we had these intervals here, and then we calculated the time elapsed. We did this number minus this number. Well, in this problem, we don't have to do that because this right here is the time elapsed. So basically what this is saying for part I is find the average velocity on the time interval 2 to 2.5. Okay, because see, it's 0.5 seconds later. So you add the 0.5 to the 2. And for part I, it would be the interval 2 to 2.1, and so on for each one. But see, in our denominator, we're not going to have to do 2.5 minus 2 because they already give it to us right here. All right, so but it is important that you realize this is from the interval, is on the interval 2 to 2.5, and they're just giving us the elapsed time already. All right, so for this one, the average velocity, well, that's going to be what? Y of 2.5 minus y of 2 over 0.5. And yeah, look, if you wanted to, you could do the 2.5 minus 2, same thing. Okay, same thing. It's just they give it to us already. And so this is going to be, let's see, 40 times 2.5 minus 16 times 2.5 squared minus, and then I plug the 2 in, so that's going to be 40 times 2 minus 16 times 2 squared. And that's all over 0.5. And that gives us a value of negative 32. Okay? And then for the second one, now I'm not going to do them all out like this. I'll just write it in here and write the answer down. So that's going to be what? The average velocity is going to be y of 2.1 minus y of 2 over the elapsed time, which is 0.1. And that gives us negative 25.6. Okay. And then for part 3, the average velocity, 0.05 seconds. Now, keep in mind, this interval here, that was what? That was 2 to 2.1. This interval is what? 2 to 2.05. And so that's going to be y of 2.05 minus y of 2 over 0.05. And that is equal to negative 24.8. Okay, and this is feet per second. So I don't know if I got enough room there. Feet per second, and this is feet per second. And then for the fourth part, the average velocity, say, okay, so that's over the time interval 0.01 seconds. So that's the interval, what, 2 to 2.01. So that is y of 2.01 minus y of 2 over 0.01, and that gives us negative 24.16, and that's feet per second. Okay, so these are the answers they wanted for part A. See, part A, you had 4 parts to part A. And then for part B, they wanted to know the instantaneous velocity when t equals 2. Okay, so the instantaneous velocity when t equals 2 is, so think about it. What do you think it's going to be? Well, let's look what happened. You see how these intervals here, they got shorter and shorter, right? Okay, and then if you notice, see, we started at 2.5 and then we went to 2.1, 2.05, 2.01. These values here that I have underlined in green, what are they doing? They're getting closer and closer to 2. And so as these values got closer and closer to 2, well, what do you think this velocity is approaching? We could say 24 feet per second. Okay, so yeah, that's quite a bit of work to get all this, but hopefully it'll get you an understanding or an idea of limits. Okay, and like I said, later on in your calculus class, you're going to learn an easier way to do this. Okay, I mean, it's we could find the instantaneous velocity of this at t equals 2 in 2 steps. Okay, you find the derivative and then plug the 2 in. Okay, but we don't know how to take derivatives yet. That's what we're going to learn. We got to learn limits first. Okay, so I hope this video helped. Hope it made sense. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.